CRAISE is climate resilient agriculture through integrated systems and emerging technology. Climate change poses significant threats to global food security, particularly in developing countries like Uganda. Millions depend on agriculture. The rising temperature, erratic rainfall patterns, all these challenges affect food security, livelihood, and economic stability. Despite our efforts to make sure that we have sustainable agriculture or agricultural practices, the rainfall pattern is low due to these limited innovative solutions. We face a lot of inadequate yields that affects the knowledge dissemination. And as CRAISE, we are transforming through our objectives of increasing enhanced productivity, resilience, through the use of greenhouse gas emissions, and also by leveraging the use of emerging technologies, machine learning, that will help reduce the adverse effects of climate change. Our main goal of this project is to carry out research that will look at the different crop varieties that can be grown in different agroecological zones. Our main target is to use agriculture intelligence using remote sensing, precisions, and blockchain to help us make precisions through data-driven approach. We will combine the different strategies and different digital tools to enable us achieve our objectives. Our first objective would be basically to enhance climate resilience, agriculture productivity through adaptive integrated system and emerging technologies in Uganda. Particularly, we will be able to develop and integrate agricultural systems that will enable climate resilience and sustainability. Our pilot will begin with a web-based application that will use machine learning to enable us determine the soil moisture level in the soil. This will help us in data-driven decision-making and supply chain efficiency. Particularly, we will strengthen the farmers' capacity and extension workers, even the policy makers, through the use of these technologies. To contribute to the national and regional policies, we will have evidence-based research that will help us achieve this. Our outcome would be an increase in the climate resilient practices that will target about 40% of farmers. This will help us increase the crop yields by 50% and reduce the post-harvest losses by 15%. Our target is to skill over 10,000 farmers and 500 extension workers through the use of our mobile-based technologies. Our approach would also help the policymakers be briefed about the climate-smart agriculture strategies that are there. Our approach is also going to lead to technologies and innovations that can solve different challenges in crop varieties with integrated water management systems, which involves the use of automated irrigation systems. We will have also a mobile support system that will help farmers with real-time predictions of the different weather patterns. This will enable us to get better yields of different crops. Our target is also going to be to reduce on the issues of counterfeits by use of emerging technologies like blockchain. And this will enable us eliminate the counterfeits in the supply chain. Our approach will also help different farmers through knowledge and information. And knowledge and information can be achieved by training farmers on climate resilient practices. We will, based on different case studies, paper research, journals, to help us come up with the best integrated systems and that can be used in the climate smart agri-food systems. Specifically, we will use different scientific publications and briefs to help us in building the capacity of different farmers and extension workers. Our approach is to make sure that we have at least a hands-on demonstrations in the farming as they learn. We'll have a baseline assessment where we will conduct surveys and also focus on group discussion to help us assess the current practices and the challenges. We'll also use technology piloting. Technology piloting, we will implement agriculture intelligence precision tools for remote sensing and also blockchain systems in selected region. Our approach will also be to test and refine the integrated systems for the soil moisture in different agroecological zones. We will also organize a capacity building in workshops, train, and also help to demonstrate on the use of our technologies. We will try our best not to allow our work die by doing an MOE, monitoring and evaluation. We'll be able to collect, analyze data, and use different productive and resilience indicator to help us come up with the better approaches for the different indicators of the system. The different ways how we will be able to achieve this is we will try to employ the quantitative data and also look at the soil health, crop yields, and then also the water use. But our interest will be on the soil health matrix. This data, we can also provide them as open data for different data scientists to build algorithms that can also be used on our modules to inform or better the recommendations. We will also look at the different machine learning modules that will help us in the predictive analysis in our advanced analytics of remote sensor data, since our data will be collected with our low-cost IoT data sensors. The challenges that we might face could be due to the different digital literacies among farmers. We will try as much as possible to educate the farmers on the use of the different technologies. We anticipate challenges in the development of user tools that can be used by these farmers. And we will also look at the different challenges, especially in the new practices, how we can engage and demonstrate for the economic benefits of the use of our system. Our societal management ideas on environment will also look at the biodiversity of the different integrated systems. The other challenge would also be on the use of the green gas emission from the different sustainable practices. We anticipate some positive impacts and negative impacts. The negative impacts could be the displacement of the traditional agricultural practices using the manual systems. We will also look at the different mitigation strategies or measures that will help us conduct environmental impact assessments to all the interventions, and we will only focus on monitoring and evaluating the social and environmental outcomes in our approach. Agriculture in general has risks that are related to management, and some of the risks may include physical risk like extreme weather that basically affects the implementations or the early warnings that can be detected in the crops. Our main approach is also to look at the different integrations of pests and diseases that can also be that can also be controlled using the biocontrol or the traditional methods. There are some few challenges that can come through the operational risk. And with all this, if we implement the CRAISE project, this would reduce on the delays. We will also look at the development of some of this technology to maintain stakeholder engagement so that we can develop a contingency plan that will help us succeed. There are also risk management tools that can also be seen that can be handled using the different hierarchy, like the use of risk matrices and also control measures. Regular monitoring and adaptive management strategies can also be applied in regards to the climate resilient system. We'll have strategies how we can communicate, create a physical visibility of this project through disseminating our findings in workshops, radio programs, and the social media platforms. This will help us in a peer-reviewed journal at different conferences. We'll also do knowledge sharing to establish platforms where people can get access to our research work. We'll also try to collaborate with different media teams so that we create an outreach program where we reach the end users.